Imagine a world decades ago when the word AI was just a distant dream. This was a time when computers were the size of rooms, and the idea of a thinking machine was merely a fantasy, a concept relegated to the realm of science fiction. Yet, even in this nascent stage of technology, the seedlings of what we now know as artificial intelligence were beginning to sprout. In the mid-20th century, a group of ambitious scientists and mathematicians dared to dream of machines that could mimic the human mind. This dream led to the birth of a revolutionary concept: neural networks. The idea was simple, yet profound. If we could model a machine on the human brain, with its billions of neurons and intricate web of connections, we could create a system that learns, adapts, and thinks. However, the path to realizing this dream was fraught with challenges. The computational power required to run these complex models was immense, far beyond what was available at the time. The computers of the 1950s were rudimentary machines, capable of performing simple calculations, but ill-equipped to handle the intricate workings of a neural network. Moreover, the data required to train these networks was scarce. Unlike today, when we are awash in a sea of digital information, the data landscape of the 1950s was barren. Without sufficient data, these early neural networks struggled to learn, to adapt, and to grow. Yet these challenges did not dampen the spirits of those early pioneers. They knew they were onto something big, something that could change the world. So they persevered, laying the groundwork for the incredible advancements we see today. They set the stage for a revolution in technology, a revolution that would redefine what machines could do. And just like that, the dream of AI was born, waiting to be nurtured. This was the dawn of AI, a time of beginnings, of possibilities, of dreams. It was a time when the future of technology was being shaped, one neuron at a time. And as we'll see, this was only the beginning of a fascinating journey. As technology advanced, so did the possibilities. The 80s and 90s were a time of significant growth in the field of artificial intelligence, particularly with the development of neural networks. These are essentially computing systems, inspired by the human brain, that learn to perform tasks by considering examples, generally without being programmed with any task-specific rules. A key breakthrough came in the form of backpropagation, an algorithm that effectively trained these neural networks. It's a bit like a teacher for our artificial brain, guiding it through its learning process. Backpropagation adjusts the network's internal parameters, allowing it to learn complex patterns and make accurate predictions. The impact of backpropagation was profound. It led to the rise of deep learning, a subset of machine learning that employs neural networks with several layers. These deep networks have a remarkable ability to learn from large amounts of data, enabling them to solve more complex problems. One of the shining stars from this era of deep learning was the famous LeNet convolutional neural network model. Developed by Yann LeCun in the late 90s, LeNet was designed to recognize handwritten digits and other objects in images. This seemingly simple task was a huge leap forward for AI, opening up a world of possibilities for machine vision. LeNet was the first of its kind, paving the way for future models. It sparked a revolution in the field of AI, proving that machines could not only learn, but could also interpret and understand visual data. This was a significant step towards the AI we know today, capable of recognizing faces, interpreting natural language, and even driving cars. The rise of neural networks was a pivotal chapter in the story of AI. It marked a shift from rigid, rule-based systems to flexible learning machines. The foundation was set, and AI was ready to take a leap. The 2000s saw the dawn of a new era, the era of generative models. As we stepped into the new millennium, the world of artificial intelligence took another giant leap forward with the advent of generative models. These models took the concept of learning from data to a whole new level, aiming not just to understand the data, but to generate new data that's similar. In the early days, models like Boltzmann machines and autoencoders led the charge. Boltzmann machines, named after the physicist Ludwig Boltzmann, are stochastic recurrent neural networks that learn to represent the data in a way that can generate new samples. Autoencoders, on the other hand, learn to encode the data into a lower dimensional format and then decode it back to the original form, essentially learning the underlying structure of the data. But the real game changer arrived in 2014 with the inception of Generative Adversarial Networks, or GANs, by Ian Goodfellow. The concept of GANs is rather ingenious. It involves two neural networks, the generator and the discriminator, playing a game against each other. The generator's job is to create new data, while the discriminator's job is to tell apart the real data from the fake ones generated by the generator. Over time, the generator gets better and better at fooling the discriminator, thus learning to generate realistic data. This groundbreaking concept has led to some astonishing results, from creating realistic images of people who don't exist to generating high-resolution artwork. It's as if we've given machines the ability to dream, to imagine, and to create. The era of generative models has truly revolutionized the field of artificial intelligence. It's not just about machines learning from data anymore. It's about machines creating from data. And as we continue to refine and improve these models, who knows what incredible creations the machines will dream up next? Slowly but surely, machines were learning to create. Fast forward to today, and AI has permeated every aspect of our lives. The world of artificial intelligence is vibrant, dynamic, and constantly evolving. The current landscape is marked by extraordinary advancements in generative adversarial networks, or GANs, and other generative models. These are AI systems that can create new content from scratch, be it a piece of art, a piece of music, or even a piece of writing. Imagine an AI creating a painting reminiscent of Van Gogh, or composing a symphony that could rival Mozart. It's not science fiction anymore, it's happening right now. From AI-generated portraits selling for staggering amounts at auctions, to AI-composed music albums, the creative potential of these generative models is truly awe-inspiring. But it's not just about creating art or music. Generative models are helping us solve complex problems, predict future trends, and even understand the mysteries of the universe. They're being used in healthcare to develop new drugs, in climate science to model future scenarios, and in countless other fields. Now, let's look to the future. The potential of AI is vast and largely untapped. We are just scratching the surface of what AI can do. But as we march forward, there are important ethical considerations to keep in mind. As AI systems become more powerful, issues around transparency, fairness, and privacy become even more critical. We must ensure that AI is developed and used responsibly, that it benefits everyone and does not exacerbate existing inequalities. Moreover, the impact of AI on society could be profound. It may change the way we work, learn, and interact with each other. It could redefine what it means to be creative, to be productive, to be human. The journey of AI is a testament to human ingenuity and a glimpse into our potential future. As we stand on the brink of this new era, it's an exciting and somewhat daunting time to be alive. Our challenge is to navigate this landscape with wisdom, caution, and a spirit of exploration. The journey of AI is far from over, it's only just beginning. From the dawn of thinking machines to the rise of creative AI, it's been quite a journey. A journey that has seen us evolve from the rudimentary concept of artificial intelligence to the sophisticated neural networks, and now to the intriguing world of generative models. Our expedition commenced with the birth of AI, a concept that seemed like a far-fetched idea in the beginning, but over time transformed into a reality that's deeply ingrained in our everyday lives. Machines started to think, to learn, and to adapt, creating a foundation for a future that was once only imagined in science fiction. We then delved into the rise of neural networks, the biological inspiration behind the learning capabilities of AI. Like a human brain, these networks learn from experience, adjust to new inputs, and perform tasks without explicit programming. It's a fascinating phenomenon, where machines started mimicking the human brain's intricate workings, becoming more efficient and intelligent with each passing day. As we moved ahead, we encountered the era of generative models. These models brought creativity to the table, allowing AI to generate new data that resembled the input data. Whether it's creating a new piece of art, composing music, or even writing scripts, generative models have shown that AI is not just about computation and logic, but also about creativity and innovation. And here we are, in the current landscape of AI, where advancements are being made at an unprecedented rate. The potential of AI is immense, and it's not just about making our lives easier or more convenient. It's about transforming the way we live, work, and interact with the world around us. As we continue to evolve, so will AI. And who knows what the future holds, but one thing is certain, the journey is just as fascinating as the destination. As we stand on the cusp of a new era, we can only imagine the possibilities that lie ahead. The story of AI is still being written, and we are all a part of this exciting narrative. Let's continue to explore, innovate, and create, for the best is yet to come.